This is the eSolution for problem 10 in Siegel's biochemical calculations. Again, problem 10. And this appears in page 320. Okay, so the problem states that the 1 over Vx of a reciprocal plot is labeled. Okay, so let's put the plot here first and rewrite what he's stating. So we know that this plot is coming by 1 over V and 1 over S. He's talking about the double reciprocal plot, so let's do that already. And he says that the V to the minus 1, which is this one here, V minus 1, comes in the following units: nanomoles per liter per minute. So basically gives nanomole per liter per minute. Liter minus 1. I'm going to write exactly the way that he's writing this time, okay? Minute minus 1. And multiplied by 10 to the power of 2, positive 2. And the 1 over S is labeled concentration, the reciprocal of the concentration of S, and it's labeled molarity minus 1 times 10 to minus 4. Okay, and then he says the plot intersects the two axes at 2 and 4. All right, more information here. He says that this number here is 2, and this other number there is minus 4. Okay, and he asks us to calculate the values for Vmax and Km. So he wants us to know Vmax and Km. So this is a simple problem. The only thing that you have to keep in mind is that these units are already multiplied by this factor here. So you have to take that into consideration, okay? So we know from this our studies that this number that appears here, this is related to the Vmax. In other words, 1 over Vmax is going to be equals 2, but we have to adjust the unit because the unit in the x here was already multiplied by 10 to the power of 2. So now we have to take it back to the original value by divided by the 10 to the power of 2. In other words, multiply to 10 to the power of negative 2. That was the only problem there for that. That could get you in trouble, okay? So therefore, the Vmax is going to be equal 1 over 2, 10 to the power of negative 2, which gives you 50. And what's the unit that we have for molarity here? Nanomole per liter. So let's put here nanomolar, and the unit for this it was also minute, right? So that per minute. Okay, so no big deal. The only thing that we need to know how to handle these values when they are given this such a format. And what we get from here, from there we know that 1 over Km, that's the crossing line there, right? The intersection. And because this is negative, we can say that 1 over Km equals 4. But for what? Remember, this was already compensated by this value here. So we have to multiply by 10 to the power of 4 to arrive to the original number, right? Therefore, Km is going to be equal 1 over 4 times to the 4, which is 0.25 minus. Yeah, so that's going to be 2.5, 10 to the power of negative 5 molar. So that will be the Vmax and the Km for this very simple problem. Solution for problem 10 in Siegel's biochemical calculations, page 320.